بسم الله الرحمن الرحيم. In this lecture, we are going to speak about the fundamental theorem of calculus. And this one can be divided into two parts, part one and part two. In the part one, we say that if f is continuous function on a given closed interval a to b, continuous and a closed interval a and b, then the function g defined by g of x from a to x, where x is just any number or any value between a and b, of the given function f of t dt is continuous on AB. That means that we define the function g of x as integral form, because this is sometimes integral form. So g of x is equal to integral or different integral from a to x. X is any point between a and b. And in this case, the given function is continuous and also differentiable over or on the given interval a, b. And also g prime of x equal to f of x. So we have three things now. The defined function g of x is continuous, number one. Number two, it is differentiable on over interval a and b. Number three, the derivative for this function will give me f of x. So it is just like that. We are finding the area under the curve, but x is not equal to x. So it is not equal to b. It is any value between a and b. As a direct application for this theorem, we have these examples. Use part one of the fundamental theorem of calculus to find the derivative of the function. Question number 9, we are given g of x equal to 0 to x square root of t plus t to the power 3 dt. You have to notice one thing, that the variable in the integration is different from the upper limit. We are not using the same notation. This is just to make it different. So we can say that what is inside the integration is dummy variable, we can say. Now, question number 9. The derivative of g of x is equal to the function inside the integration. So it is equal to square root of instead of t, because I'm using x, that will be x plus x to the power 3. From the fundamental theorem, part 1, we say that the derivative for the function equal to the function itself. Derivative of g is equal to f of x. Let's just remove the integration sign and replace the variable t by x. Number 10. Derivative of g of x there is equal to ln 1 plus x squared. 1 plus x squared. Number 11, g of w or g prime just this again. G prime of w is equal to sine 1 plus omega or w to the power 3. Number 12, h prime of u is equal to square root of u divided by u plus 1. We have to use the same variable there. The value, so the value of it is u, I will write u. Number 13, capital F prime of x. For this one, we have x to 0, not 0 to x. We have x is just the lower limit of the integration. So the function f of x, which is equal to x to 0, 1 plus secant of t, can be written as negative from 0 to x, square root of 1 plus secant. So if we just change or swap between the limits, then we have to multiply by negative. So use this one to find the derivative for the given function. F prime in this case will be equal to negative of square root of 1 plus secant of x. So this is the first part of the fundamental theorem of calculus. The given function with g is defined as integral form of the function 0 to x, and this function is continuous, differentiable, and g prime equal to f of x. Just make it short like this. In the second part of this lecture, we are going to speak about the second part of the fundamental theorem of calculus. That if we need to find for the definite second part, this will be given later on from a to b, f of x dx is equal to capital F of b minus capital F of a. This will be discussed in details in the coming lecture.